Oh my goodness, where did I go? Hey there, hi there, ho there. Welcome back, Unit 8, Mass Wasting, new background. How's it going? Let's jump into this. So, when I say mass wasting, the most common term used is landslides. Well, no. So, there's landslides a particular type of mass wasting. All right, so we're going to be talking about all of them. They're not all called landslides. That's a common misconception. So there are different types of mass wastings, as mentioned. So it's any type of downslope movement of earth material that includes soil, dirt, rock, snow, water, trees, whatever. The movement can include some sliding. It can include some falling. It can include some flowing, or a combination of two or more of the above. And that's typically what it is. It's, we'll go through the different types, but it usually is some weird combination, complex combination of a few of these things. They include rotational landslides, translational landslides. We'll go through all these block slides, rock falls, topples, debris flows, debris avalanches, earth flows, and creep. So they're all different. Okay, so there's only two kinds of landslides. Here they are. Everything else is something different. So that's why they're not all landslides. So rotational landslide is a slide in which the surface of rupture is curved concavely upward, and the slide movement is roughly rotational. So it kind of curves out. You can see the surface of rupture where the material is breaking away from the material below it is kind of curved. So it kind of does this kind of rotational thing and then out and down. So you can kind of see a little bit this kind of curved nature to it. So this is a little baby rotational landslide. Then you have translational landslides. This is just a straight shot. The landslide mass moves along a roughly planar surface with little rotation. It's pretty much just a kind of a straight shot down. So again, there's not much curve to it. It's just kind of a straight down. So that'd be a translational landslide. We have block slides. It's a translational slide in which the moving mass consists of typically a single unit or a few closely related units, even a big block of rock or a few big blocks of rock that move downslope as a relatively coherent mass. So it's not a bunch of dirt and small rocks. It's just kind of a big thing kind of moving on its own. So you can, for reference, you can kind of see the little scientist here for reference, but you can imagine kind of these big chunks that break off here just kind of slide down the face in kind of one big chunk. We have rock falls. Now, falls are when material, mostly rocks and boulders, become detached from the steep slope or cliffs, and there's some sort of free fall involved. So it gets some air. So when we're talking about a rock fall, it's got to be in the air at some point. It's got to come straight down and fall off. There's no kind of sliding to it. It's just going to, like, big pieces kind of just falling off. So you can imagine off this vertical cliff, nothing is going to slide down it. If pieces fall off, they're just going to fall off. They'll eventually hit this part and stumble down, but they're getting that air, as it were. So gravity is the thing just pulling it down through the air, typically. Somewhat similar is a topple. So this is distinguished by some forward rotation of some sort of land unit. So it doesn't really get some air, but it was here, and it just kind of topples forward. It doesn't like go up and free fall through the air. So this looks like some topple area, which is kind of right here, but just kind of toppled over. That's what it looks like there. Now, a little bit different even are debris flows. So in this case, you get a combination of loose soil, loose dirt, rock, organic material, plants, trees, air, and water, all kind of working together to form this slurry, this slushy material that all flows down slope. So you get a bunch of stuff mixed into it. Landslides are just kind of big, like the material itself just all moving. But this, you're really mixing in a lot of stuff for this stuff to start flowing. It's almost like a shake. It's kind of brown like a chocolate shake. So you take all these different ingredients, kind of mix them up, and then slide them downhill. Commonly caused by intense surface water flow, heavy rains, heavy precipitation, rapid snow melt. So they're kind of work in context with flash floods. Flash floods. You can also this type of mass wasting event is very common where there's wildfires. Wildfires come in that burns a bunch of vegetation on a slope on a hill, so the trees, bushes, whatever. Heavy rains, so you get all that water mixing in with the dirt, mixing with the ash and all the burnt sticks and all that stuff. It kind of forms that chocolate shake, and then it slides on down, a big mushy, slushy flow. So it's a debris flow. Again, it can be full of mud and rocks and dirt and sticks and twigs, and some of these boulders are probably about as big, in fact, bigger than a car. So again, they kind of work in context with flash floods. So debris avalanche is basically a debris flow, but it moves really, really fast. In order for it to move really, really fast, it's got on a really, really, really steep angle. So both kind of the same thing. It's just it's on such a steep angle, it just moves real fast. So you get a debris avalanche. Debris avalanche. See, with slides, you can typically, not always, but like see like what you saw, what would have been there, kind of in some part make its way down to the bottom. A flow is really just all that stuff kind of mixed together, and you can't really, make out what was there before, because it should look just like this and this. So anyway, debris avalanche. You get something called an earth flow. This is characteristic, has a characteristic hourglass shape, so a little bulb at the top, little bulb at the bottom, and kind of skinny in between. The slope material liquefies, runs out, forming a bowl or depression at the head, and it's not like the whole slope failed, it's just some part up here, and then it kind of flowed out. So you can see here's an example of just that. So the material wasn't the whole slope, it was just this little bit up here, and it liquefied, turned to a slurry, and you can kind of see it coming all the way down here, and there is your bulb shape for an earth flow. And then you get creep, right? A, B, C, D, E, F, G, H, I. You get a creep. This is the 9th one. Creeps, not like in a creeper. Well, I guess kind of like a creeper. Like a creeper moves like really slow. Well, same thing with this type of mass wasting. Creep, very, very slow, imperceptibly slow. You can't even see the movement itself. It's very slow, very steady. We're talking maybe an inch a year or something like that. Something you can't even detect. So it's the whole material kind of moving. But what helps you detect creep, and it's kind of everything moving with it, the land, fences, trees. What can help you is bent fencing. So, after a couple years, your fence is kind of a different shape. That might indicate creep. Tilted telephone poles or electric poles, small ripples in the soil, or curved tree trunks. So, with creep happening, let's see if I can back up a little bit. This might be better with my pen. All right, so if the land begins to creep, all right, the tree might kind of rotate a little bit. But trees and plants always want to grow up towards the sun. So what you'll see is that the tree will start to correct for that creep. It'll happen again. It'll correct for that creep. It happen again, and it corrects for that creep. So as the slope continues to move kind of downhill, the trees kind of correct themselves and continually grow upward, so they kind of curve, they kind of start to grow curved and upwards, but this is a good indication of creep, is seeing these curved tree trunks. You can see it all the way in the background. So this slope is moving very, very slow. Slow enough that trees have been able to grow and recorrect the direction they're going based on the movement. So that happens really, really slow. It takes a long time for a tree to correct its growth to go vertical. That's a good indication of creep. And then I like to usually throw on avalanches. It is a downslope movement of material. It doesn't normally get discussed, because it's not the land itself, it's something that was added to it failing. but we'll throw it in for good measure. So heavy snowfall, wind, movements of people, animals, whatever, a lot of things can trigger an avalanche. It usually occurs when some heavy layer of snow is layered on top of an unstable, weaker layer of snow. So heavy new snow piles up on a weaker layer of snow. For some reason that there's some sort of rupture there, and it breaks away, and it kind of slides along this other layer. So let's say it snows, it snows, and then it stops for a couple days. Some of that material on the surface is melting, like recrystallizing, and then it snows again. And so now you got this fresh snow on this kind of other snow, and so there's a kind of a layer between it. There's a boundary between it in which that's kind of unstable. It's not one coherent thing. So that's typically where you get some avalanches occurring. And there's different types of avalanches, slabs, loose snow. Different avalanches are defined on how they flow. Do they get air? Are they on the ground? Are they kind of mixed between the two? It depends on the type of snow. Blah 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 blah. So that's a whole nother unit in itself. But side note, I know most of us live in hot Phoenix area, but just in case you ever find yourself in an avalanche, what you want to do is, if you can, if you're going downhill, point your feet downhill and try to dig your feet into the kind of bedrock surface underneath the snow, and try to do the backstroke uphill. I mean, you're still going to be going downhill, but at least that might keep you up. And if for some reason you get caught in the avalanche and you're tumbling, once that mass comes to a stop and you're in it, it's going to just form concrete, essentially. You're just essentially going to get locked into it and hoping that someone can find you, because if not, you'll suffocate probably within minutes or hours, something like that. So what you can do is put your arms, as soon as you can feel yourself, or as best you can, put your arms across your face to create kind of an air pocket. And that way, if you can move your arms in there, you'll have a little air pocket to breathe in. Because if you don't, then basically the snow turns to cement, and it's going to just cement you in and suffocate you. So don't do that. All right. So that was kind of a long one about all the different types. Just so you understand that there's different types of mass wasting. They're not all landslides. So we'll pause there. When we come back, we'll talk about the factors that might affect mass wasting. The types, those different types that we talked about, the frequency of events, etc. We'll talk about that when we come back. See you in a minute.